Okay, today we're going to look at law of sines and law of cosines. We can use both of these with any kind of triangle. We don't need a right triangle, so that's what makes them so helpful. And we can use them to find either a missing side or a missing angle, depending on the setup, on what we're given. So these are both the formulae for law of sines, and you do not have to memorize these. I'll give these to you, and we only ever use two of these at a time, two of these ratios. So, for example, we would use both both of these, or we would use both of these, or we would use both of these, but it wouldn't make sense to use all three at the same time. And notice the only difference between this block here and this block is just that they're flipped upside down. They're reciprocals of each other, and that's totally normal. You can, by the way, the uppercase letters stand for angles, and then the lowercase letters stand for the sides across from those angles. So angle A is across from side A. Angle B is across from side, angle B is across from side B. Angle C is across from side C. Okay, so then we choose two of these ratios to work with. Say for example, we were given, say we wanted to find side B, okay, and we were given side A, and angle B. We were given all of those measurements. We could set up this ratio, and that would allow us to find our unknown B. Okay, and we could set it up either way. We could set it up with the sides on the top and the angles on the bottom, or vice versa. And it doesn't matter because it is just a ratio, and we're going to be cross-multiplying to solve it. Anyhow, I do not want you to memorize this, but if you're just looking for some kind of reference as to when you can use which rule, sometimes it's difficult to visualize that. This is just a reference for you. And again, I wouldn't suggest you memorize it, but just so you can visualize it, I guess. So one of those instances is angle side. That's what the AAS means. This is for a sine rule, by the way, or law of sines. And then we'll look at law of cosines in a bit. So angle side is one of those instances. Angle side angle and side angle. Okay, and I'll talk more about what those mean, but just for your reference. Okay, so we're actually going to use the law of sines here to find the missing side. So the missing side happens to be x. So let's put that here. And then that's across from angle 13, so it's going to be over sine of 13 degrees. And then we can say, okay, this is 112, and that's across from angle 61 degrees. So 112 is going to be over sine of 61, and 123.1 is going to be over sine of 106. So we're going to use just two of these. So we could use these two to solve for x. Of course, we have to use this one because that has x in it. Or we could use not use the middle one and just use the first and last ratios to solve for x. It doesn't matter. And oftentimes you won't be given enough information to even choose, but in this case we are. So, okay, so we have our ratios, and at this point we can then cross multiply. So let's just use these two. Okay, we'll cross multiply, and by the way, when we multiply a sine function by a constant, so like in this case we're going to multiply 123.1 times sine of 13, we always put that constant in front, because otherwise if we put it behind, it gets a bit confusing. Do we multiply by 13 first, and then take the sine function, or do we do sine of 13 and then multiply. This way there's no confusion. So we will definitely do 123.1 times the sine of just the angle 13. Okay, and that's going to be equal to x times sine of 106. So this is just cross multiplication. So in your calculator then, you can do this multiplication. In fact, I'll get my Okay, so we just want to make sure that our calculator is in degrees, because we're dealing with degrees, not radians. Okay, and then we'll do, what was it, 123.1 times the sine of 13. Okay, and that's, so it's 27 point, okay, so they solved it a bit differently, but I'll write this out. So that's going to be 27, so this here is 27.6915 is equal to, and then we need to calculate sine of 106. So sine of 106. So it's 0.961262. Okay, and then we want to get x alone, right? So that's x times that. So we're going to need to divide by that decimal both sides. So we'll divide this decimal over here. Okay, and then we're just solving for x. So we're gonna, by the way, do you know you can use this up arrow to go back and get what you entered or any calculations you did? So then you just hit enter once you've got what you want, and we can divide by, and you can again use the up arrow and hit enter. And that should be it. Okay, and that does give us 28.81 units as our missing side. So x is equal to 28.81. Okay, so that's law of sines, and using that to find a missing side. This one's a little bit more challenging. Okay, so here we want to find the lengths of the ropes. So we've got x and we've got y that we need to find. So two unknowns, and notice we have, well, we have several triangles here, don't we? Okay, so we're given two angles within this triangle. But in order to use law of sines, we need to have, what do we need to have? We need to have, okay, so we're given this side here, which is across from this angle, so that's perfect. So we know we have sine of 25 across from 20. And that's going to be equal to, if we want to find x first, that's going to be equal to this angle, which we don't have currently, across from x. Okay, so over x. We can calculate that angle by doing, remember, all the angles of a triangle add up to 180 degrees. So we've got 50 degrees, we've got 25 degrees, and we've got this missing angle. Let's call that A. So 50 degrees plus 25 degrees plus A has to equal 180 degrees, right? Because it's a triangle. So that means A is going to be 105, right? Because we've got 75 plus 105 is going to give us 180. Okay, so this is 105 degrees, this angle. And so we can use the sine rule now to find x. And I believe that's on the next page. Okay, so here it is. And then we can also use law of sines to find y by using this angle over that side, and that's where this ratio came from. So we'll start by just using two of them. So these two here. And then we can use these two to find y. So the first two to find x, the second two to find y. And we'll just cross multiply again. So if we're focusing on those first two to find x, we'll have 105, sine of 105 times 20, right? So that's where this came from. And then that's still divided by sine of 25 degrees. And then we would just calculate that on our calculator. And then to set up the ratio to find y, so we're not using this middle one. We're cross multiplying, so we've got y times the sine of 25 degrees, okay, is equal to y times sine of 25 is equal to sine of 50 times 20. Okay, and then we'll want to move sine of 25 to the other side to get y alone, so we'll divide by sine of 25. And that'll move this over to the other side. Oops. Okay, and then we just plug each of those into the calculator. So when you calculate that, you'll get these decimals, and we don't even know the solution, so let's calculate them quick. Okay, so 20 divided by 0.4226 times 0.9659. Okay, so that should be, x should be about 45.7 units, and y okay, so y should be about 36.3 units. Okay. Okay, law of cosines. So we use this when we're given all three sides, so that's side, 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 or if we have side, angle, side. So what that means is we have a side, an included angle, and then another side, okay? Or the side, side, side is if we're given all three sides and we want to find any one of those angles. Okay, so the formula for law of sines, you also do not have to memorize this. It will be given to you. So this is it down here. We have c squared, which is this side here. Notice it's squared, so in the end, you'll need to take the square root. So generally, we set it up so that the unknown is c. And that's going to be equal to this side squared plus this side squared minus 2 times this side times the cosine of this angle. So if this side is what we want to find over here, then we need to have these three things given to us. Okay, or we can have all three sides given to us, and I'll show you what that looks like too. Okay, so we're given this information here. I'm just going to draw that triangle so you can visualize it. So we're given, if this is triangle ABC, we're given angle B is 34.4 degrees. We're given side A, which is going to be across from angle A, is 13.9 units, and side C, which is across from angle C, is 10. So we're given this side, we're given the included angle, and we're given this side. And we want to find the missing side. So we want to find B over here. Okay. So we're going to set it up using the law of sines. So we'll have B squared, because that's the side that we don't know. so this side here, is going to be equal to this side squared plus this side squared minus 2 times A again times C. So this is A, C. And then times the cosine of the included angle, so that's cosine of B. Okay, so that's how we set that up. And then to solve that, we just simply plug all of that into our calculator, and then we take the square root. Okay, so I'm not going to show you that. I assume that that'll be okay. Just do not forget to take the square root. That's all. Okay, and notice this is plus and this is minus, something to just be aware of. And that's just given to you in the formula. Okay, so we use law of sines to find a missing angle, but not the largest angle. Let's see. Oh, right. Okay. So if we wanted to find yeah, if we wanted to find if we wanted to find this angle here, then angle C, we could use law of sines to set that up. So we found we found this side here. We found side B. And if we still wanted to know more information about this triangle, like we wanted to know this angle, we can then set it up using law of sines. So we can say sine of 34.4 over 8, which was, so this is B over B, right? We just found this B, and we were given this angle. And that's going to be equal to sine of this angle, which is what we're trying to find now. We're trying to find C divided by the side that it's across from. Okay, and then we can cross multiply, and we can take the sine inverse. So what that'll look like is we'll have 8 times sine of C equals 10 times the sine of 34.4 degrees, and then we'll need to divide by 8. So we'll have sine of C equals 10 times the sine of, I'm running out of space. So we'll have sine of C equals 10 times the sine of 34.4 divided by 8. And then we'll need to take the sine inverse of both sides to get C by itself. So to move sine to the other side to find an angle, remember we need to do the inverse of our trig function. So we'll do sine inverse of all of that, and that'll give us C. And and C is given to us here. Okay. After you put that in the calculator. And then, of course, to find the last angle, the easiest thing to do is to do 180 minus the other two angles, because remember, we're dealing with a triangle. All angles of a triangle add up to 180 degrees. So we can do 44.9 plus what we were originally given, the 34.4, and then minus that from 180 degrees, and we get 100.7 degrees. Okay, side, side, side. If you're given this, you will use a, you'll still use the cosine rule. It just requires a little bit of algebra. There's also a different cosine rule that I will give you, but we'll look at it in this way too. Sorry, it's not a different cosine rule, it's just cosine rule solved in a different way. And we'll look at that on your homework and in class. But so for example, here, if you're given all three sides, so if we have a triangle, we have A, B, and C. So A is going to be across from angle A, which is 15. B is going to be across from angle B, which is 18. And C is going to be across from angle C, so this is 22. Okay, so then we can set this up for any angle. So if we put C squared here, then this has to be angle C. Okay, and likewise, if we're using angle C that we're trying to find, then we need to use these two sides because we need two sides in the included angle. So we've got A squared b squared minus 2 times a times b. Okay, and this is what we're trying to find, this angle C. Okay, so then it's just a matter of isolating cosine of C. You'll need to subtract 15 squared. You'll need to subtract 18 squared, so you need to move these to the other side. Okay, and then divide by negative 2 times 15 times 18 to get cosine of C alone. So this is just doing a bit of algebra. And then we'll need to take the cosine inverse of both sides. So you'll do cosine inverse to move this cosine to the other side. Okay, and then we'll just get C, and cosine inverse of that fraction is 83.1 degrees. So that gives us this angle here, is 83.1 degrees. Okay, if we wanted to find other angles, it's probably easiest to do sine rule. So if we wanted to find angle A, for example, we could, so now we know C is 83.1. We could set up the sine rule. So we have sine of 83.1 over 22. So this angle with the side across from it. And then if we want to find angle A, we'll need side A. So I have sine of A over 15. And we'll cross multiply. We'll have to do sine inverse. So what that'll look like is 22 sine of A is equal to 15 sine of 83.1. And then we want sine A alone, so we'll divide by 22. And then we'll have to take the sine inverse of both sides. So sine inverse of okay, and that's what'll get plugged into your calculator, and you should get A equals 42.6 degrees. And then for angle B, we'll have 180 degrees minus angle A, which was 42.6, minus angle C, which was 83.1, and that will give us B, which is 54.3. Okay, so these 1, 2, and 3 stand for steps that we can use. So our first step is to use law of cosines when we're given all three sides and we want to find an angle. So you can use law of cosines to find any angle. Just whatever side goes over here, that's the angle that you need to find. So likewise, we could have set this up to find angle A first, for example. So what that would have looked like is we would have had 15 squared, because that's the side across from A, is equal to, and then these, this would have been 22 squared plus still 18 squared minus 2 times 22 times 18, and then cosine of A, because this is side A. Okay, so that's the only difference. Okay, so first you'll do law of cosines to find the missing angle, to find one missing angle. Then you'll do law of sines to find the second missing angle, any of the two. And then you'll do, what do we call that? Angles of a triangle theorem. And that's just using the fact that all the angles of a triangle add up to 180 degrees and minusing the other two to get the third one. Okay. Right, so here's two more examples of that. Okay, we're just gonna do one of these examples. You're welcome to use the other one. I'll pull out the answers for you, so you can check your work. Okay, so we've got angle C is 54 degrees. So we're just using this first one here. Side A is 112. Side B is 87.2. So this is the hard part, trying to decide, okay, should we use law of sines? Should we use law of cosines? How do we go about, by the way, solving each triangle means finding all the missing sides and all the missing angles. So if you have two sides, and the included angle, right away you should see, okay, that's law of cosines. And even if you try to use law of sines, you'll run into a bit of a dead end. Like say we want to find this side C. So we have this angle and that side. So if we wanted to try law of sines, we'd have sine of 54 over C, so that's great. But then we don't have any other angles. Like we have this side, but we don't have the angle across from it. And we have this side, we have 112, but we don't have the angle across from that. So we have too many unknowns to use law of sines. So we have to start with law of cosines here. So we want to find, we're given angle C, so we want to set it up for, so we're finding side C is equal to b squared plus a squared minus 2 times a and b, so 87.2, 112, and then times the cosine of the angle that we know, 54 degrees. Okay, so you would calculate all of that, you would take the square root of both sides, and you would get side C should be equal to 93.1. Okay, so this is 93.1 units. We can then use law of sines to find either of the missing angles. So we'll set up sine of 54 degrees over 93.1 equals, yeah, either one of them. So sine of b over 87.2. We would cross multiply. We would eventually have to take the sine inverse to get b alone. And that would give us b is equal to 49.3 degrees. And then to get the last angle, we would use the fact that 180 degrees minus 49.3 minus 54 degrees is going to be equal to 76.7 degrees. Okay, and then you have one more example here if you want to try that, and oops, here are the solutions for that one. Okay, so in number 2 you're given all 3 sides, and then you need to find all 3 angles. Okay, so like I said, I don't want you to remember these kind of things, but really it's honestly easiest to remember it for law of cosines. So if you're given a side, an included angle, and then the side, so side, angle, side, you need to use law of cosines. That's an example we just did for number 1 here. We were given a side, the included angle, and a side. So it's definitely law of cosines. And like we talked about, if you're given all 3 sides, that's also law of cosines. Okay, so if you're given this side, and this side, and you need to find an angle, you have to use law of cosines. All the rest, we can use law of sines. Okay, so those ones for law of sines you don't really have to memorize. It's important that you're able to recognize law of cosines. So okay, is this the last? Yes, okay, last example. We're given a parallelogram. We want to find the length of the longer diagonal. So these are the diagonals of a parallelogram. Obviously, the longer one is here. We don't know how it's going to cut this angle here. But we do know that this is going to be its supplementary angle. Okay, so this angle, just based on the theorems of a parallelogram, this is going to be 180 degrees minus 55 degrees. Okay, so that's going to be 25 degrees, right? Okay, I know, 125. Okay, so this is 125 degrees. Okay, so really we're looking at I'm just going to pull that triangle out so it's less to look at. This is 125 degrees. We know this side is 7.3, and we know this side is 3.8. So hopefully right away you can see what rule we're going to use if we want to find the longest side of the longest diagonal here. So hopefully you recognize we have a side, we have an included angle, and we have a side. So we need to use law of cosines. And we'll set that up as, so if d is the longer diagonal, we'll have d squared is equal to 7.3 squared plus 3.8 squared minus 2 times 7.3 times 3.8 times the cosine of the included angle. So cosine of 125 degrees. We'll calculate all of that. Don't forget to take the square root of both sides, and you'll get d is equal to about 10 centimeters. Okay, thank you very much.